Okay, so this is a continuation of the Beginner's Guide to SDL2 and CppF2. If you have just started with this video, you will need to clone the repository at Programming Rainbow, Beginner's Guide to Beginner's Guide to SDL2 and CppF2. You will also need to get Herb Sutter's CppFront from inside of the directory after you have cloned this repository. When you cd inside of it, from inside this directory, you will also need to clone CppFront, and you will need to compile that. That's in the very first video. If you watch the first video in the series, I'll assume that that's already installed. So this is the fourth video. We will be working with the code that we have been working with the whole time. So that will be the code that is now in the third video folder. If you copy that source file out just into the source folder, you'll be caught up with where we are here. So we have already made the window open and close. Now we want to draw something on the window. But to do that, we are going to need access to another library. Or it's a module for SDL2. We're going to need SDL2 image library. So we're going to need a module from SDL2 called the image, because SDL2 by itself, we can load bitmap images, but I actually want to load PNG images, not bitmap images. So we are going to use the SDL2. We're going to have to start this one up just like we did SDL, and then we're going to close it down. So this is SDL2 image. Okay, you're going to need this installed on your system. So for the image module, we can pass some flags into it, and this is going to be a little bit funny when we're dealing with whether this thing started up or not, because what we get out of it is the answer. We put flags into it, and then we're going to receive flags out of it. So the function loads dynamic libraries, needs to prepare them for use, and must be first function. Okay. Flag should be one of, yeah. Okay, so we are going to specifically be using, for this, we're going to be using image init PNG, but you can actually have multiple of these. But for this video, we're going to be using PNG, but I'll set it up that where if you need to change it, you can use yours. And the way we check it is going to be a little bit interesting. So let's work on that first. So we're in here. First, we're going to need to include the that SDL2 image. So that's for my system, it's in a subfolder called SDL2, and that's SDL2 image.h. That's the header file giving us access to the module. And we're gonna go down to where we initialize SDL down here. We're gonna do something similar, but it's not gonna be the exact same. So the program is that image img.init. So right away that is what we want, right? img init. But we need a flag, and I said I want to use the image init PNG flag. But because the way I want to check it and stuff, I'm actually going to set a variable up here, and I'm going to call it image flags. And this is going to be an an I32. It's just a normal int. And I'm going to set it to this img init PNG. Okay, and we can actually do this for SDL as well. So I'm just going to do that real quick. SDL flags. Maybe I should have done that initially. It makes it a little bit easier for you to change things later. I'm just taking this right here, this flags that's right here. I'm just putting it up here because you can combine these. Now the everything flag is, you're not really combining that, but let's say you had some of the other flags, you can actually combine them. Everything. So that means down here in SDL, we can just put our SDL flags, yeah. And the same for this new function that's setting up the image module. We can use image flags, okay? And that's going to be the image init PNG. But like I said, you can actually use more than one flag together. Now the problem with this is it's going to return from this function not what flags we put in, but what flags actually got set. So we're asking it to turn on PNG, but maybe it actually turned on bitmap and not PNG. So that's gonna be the answer coming out. Is going to be an I32 that's actually encoded to what was actually set. So I'm going to attempt to explain this real quick. What's happening? So imagine we have I'm just going to use a 4-bit. Not a 32-bit. I'm just going to use 4 bits to try to explain this real quick. But imagine we could have bitmaps, we could have PNG, we could have TIFF, we could have JPEG. Let's say that, right? So we have 4 bits, right? So 000 is nothing's turned on, right? But let's say let's put it up here. Let's say I don't remember. Is it BMP? BMP is bitmap. And then PNG and TIFF and JPEG, right? Maybe we just put 1F. Doesn't matter. So imagine we have these 4, and bitmap is represented by the topmost bit. PNG is represented by the next bit, and TIFF is and JPEGs, right? So if we wanted all of them, it would be 1111, right? So this is going to be in binary. This is going to be, so this is 15. So this is a binary representation of 15. Do you get it? So these can be 1s or 0s, but 4 1s in binary is 15. Okay. So imagine that this function is looking at that. It's not thinking about 15. It's thinking about, is the first bit set? Is the second bit set? Is the third bit set? Right. So if I wanted, say, if I wanted all of them turned on, it'd be 15. If I wanted just PNG turned on, it would be like this. That's just PNG is turned on, right? So that's what is that, 4? Yeah, that's 4. So that would just represent 4, right? And then 5 would represent PNG's turned on and JPEG is turned on. Okay, and you can do a bitwise ands and ors. So imagine imagine I had one flag was for PNG, and I have another flag that is for JPEG. So I got 001, right? And I want to set both of these. I want to turn both of these things on. So I could use a bitwise. So I could use an OR. Sorry. So a single pipe is an OR, and what this becomes equal to is it's 0 or 0. Well, that's 0. Now it's 1 or 0, and that's 1. And it's 0 or 0, that's 0. And then 0 or 1, and it's 1. Okay, that's a bitwise OR. And my answer in the end is, hey, turn on PNG and turn on JPEG. So if I had 2 of these flags, I can actually use a bitwise OR operator to get the answer of both of them. Okay? And that's cool for that. But imagine this. Imagine I'm putting in a flag here, and then I'm getting an answer back here. I don't care about the answer. I only care about the answer insofar as it might be answering multiple questions, but I only want the answer to my question. If I ask for PNG turned on, I don't care if it's telling me bitmap is turned on and JPEG is turned on. I only care if PNG was turned on. So imagine this. Imagine I tell it to turn on PNG, which is 00. Sorry, PNG is 01. These are just made up things I'm doing here, but this is just an example. And it spits out that both bitmap and PNG were turned on. Okay. I can't check these to see if they're equivalent now. Okay? even though the thing I wanted turned on is actually turned on. I can't check it this way. I can't say, you know, does this equal this? It's going to fail. I can't do that. That's a false, right? So what I need to do is I need to mask out the information that I don't want to know. So if I use, instead of an OR operator, if I use an AND, a bitwise AND like this, now my answer becomes more interesting because it is 0 and 1. 0 and 1 in binary logic, bitwise, in the bitwise AND, not the logical AND, is different. 0 and 1 is 0. It equals 0. And 1 and 1, 1 and 1, they both have to be 1, is 1. 0 and 0 is 0. And 0 and 0 is still 0. So my answer is this. So this is what I wanted. This is what I got. And then when I mask out what I wanted from what I got, I get the answer. Now I can compare this with this. Now imagine it wasn't turned on. Instead, it was like this. So my answer becomes 0 and 1 is 0. 1 and 0 is 0. And 0 and 1 is 0. And 0 and 0 is 0. So now I check, was my PNG turned on? No, it wasn't. So what's going to happen here is I'm going to put in my flags. I'm going to, this is called a mask. I'm going to mask out what I want, I'm going to mask out only the answer I want, and then I'm going to check to see if that masked answer is actually my original answer. So that's a very long way to explain it, but it's going to look like this. It's going to look a bit weird, but I'm going to put this in an if statement. I'm going to say if. Remember, this is returning a number. So all these are numbers. Now this one has a bunch of numbers turned on, but this one probably just has one number turned on. So here's my I'm setting my image here, right? It's a number. So I'm putting it in here, and this thing's going to spit out a number. And I need to mask that. So I'm going to use an AND. And I'm just going to use my original image flags, right? Now I need to see, does that actually equal or not equal? Because the if statement is the false here. So I'm going to say it's not equal to image flags. I need to put another parentheses here. Let's see where we're at, and another one over here. So this if statement is looking for the failure, not the success. Okay? So this says, here's the flags. Now I got an answer out of what actually happened. I'm using my flags and the bitwise AND operator to mask out the answer, only the answer to the question I want. I don't care about anything else that happened. I only want to know about the things I wanted to happen. And now, if they didn't happen, we got a problem. We got an error. So I know that's a very long way, but this is bitwise. Now, so if we do this, we could actually set more than one here. We could say, we could do this, and we could go like this, and we could say image init. Is it JPEG? I don't even know what it is. But we could do this, and we can now have two of these. We might need, I don't know in the syntax of this if we need to put this in parentheses. I'm not sure the actual thing, but or if it even, it should, because it lets us do it here. But in C or C++, I would do something like this if I wanted more than one flag. But I'm not using more than one flag right now. But this is just a very long way to know, did the thing I want to happen? So the flag goes in, the flags come out, mask out the answer I actually want, and check it to see if that didn't happen. And then we're going to bail out if it didn't happen. I'm going to delete all this stuff. So now this is an error coming from the image module. Instead of using SDL get error, I'm going to use image get error. Okay. Now, I believe internally inside of the SDL image module that this is just pointing to SDL get error, but no, whether it is or not, I'm just going to use the image get error. So we can say error initializing SDL image and then return that error. So I know that was very complicated, but that's how we're going to initialize. And the way that we are going to shut it down is in reverse order. So first I'm bringing SDL online, then I'm bringing SDL image online. So first I'm going to shut down SDL image, which is image quit, and this is a void function. Should be right. Where is it? Is it here? Image quit is a void function. It just shuts down the image module. So I shut things down in the reverse order that I started them up. So start up SDL, start up image, shut down image, shut down SDL. Okay, and we have the header file there. So let's just compile that and make sure it works. We will need to add, so we first got to use CppFront. Now we will need to add to our line before. Before we had just going on from SDL2, but now we need to add SDL2 image for the linker. So the linker knows that we need that library as well. Okay, I've made a mistake, so let's find out. Oh, no. Oh, I sorry. I know what I'm doing. I'm not using the source directory. I'm using the video 10. I was in between videos. I was doing something else. So this needs to be source, but we also have the problem of this needs to be, did the other command I run, was it against the correct folder? Yeah, that's also the wrong folder. So this needs to be source. And then this command here also needs to be from the source folder. Okay. Now that's an error for us this time. Include, did not find include. So I probably put a semicolon somewhere I shouldn't have. Oh, I didn't. SDL2, SDL image. What was the error again? Oh, I spelled include wrong. Okay. Got the two letters backwards when I was typing. So CppFront again, and then this one again. Okay. Now we're going to run it, and we won't see any different because we're really just starting up and shutting down. But it's all working, so that's good. So now that we have that online, let's load up an image. So we're going to use this, another thing from the image module. The reason why we needed to turn on this image module is because we need to get access to loading images that are not bitmap images. So we want to load a PNG image. We're not going to load it we're not going to load it to a surface and then convert the surface to a texture. We're going to load it directly to a texture because we can do that here. So because we're loading it directly to a hardware accelerated GPU texture, we are going to be using the renderer, and then we just need the name of the file. So this function is returning a SDL texture. Now this is an SDL texture, it's not image. The function is part of the image module, but the texture is part of SDL. So it's returning an SDL texture. It takes the render and it takes the file, the name of the file that we're loading. And the name of the file that we are loading, if I can open it up here, it's in images and it's just called background PNG. Okay, so I'm going to close that again. So this is going to be another unique pointer. So we're going to put right here next to our unique pointers, and we'll call it background. So this is another unique pointer, std unique pointer, and this is the type is an SDL texture. The destructor is the SDL destroy texture. That was the function that we just looked at here. The load image, sorry, I don't know if we looked at it. To destroy a texture, we just need to call this function and we need to pass in the texture to it. So this is SDL destroy texture. And it's okay if we pass null into it. If it hasn't been created yet, it checks for null first before if it just returns right away if it sees null. So we got a unique pointer. It's of type texture. Its deleter is a SDL destroy texture, and we need the ampersand on the back end of it. And this one is going to be initialized to a null pointer. Just wondering if that needs to be set. I'm not quite sure on that one. Destroy texture. Okay. So now let's load the texture, and I'm not going to do it here. This is in the initialization. I'm going to make another member function called load media, where we do all the loading of the media. This is going to initialize the SDL part that needs to happen in the game, but the other one is going to just be responsible for loading images and sound files and music and stuff like that. And this will be in out this. Okay, and this is where we will be loading, we'll be calling that function the image load texture right here. And this will be on the reset of the background. So we got background at reset, and here's our function. We first need to send in the render, and it needs to be the raw pointer. The render, and the next is the location. So it's in subfolder images, and it's called background PNG. So that will be images background.png. I'm just going to close that because it's taking up too much space. So that's the function that we're running. And then we need to check to make sure it was actually created. And we're gonna do it just like we've done with these, pretty much. I'm just gonna copy this. But we need to change the render to background. And the error is coming from image. And it's going to be error loading texture. So error loading texture, that throws the error. Okay, now we're going to call this load media after we call initialize in the constructor. Okay, and I did forget, I think I forgot to, no, I didn't. Okay, I do have the image quit down here. So that is, we've got the unique pointer. We have it in a member function called load media. So it should be loading that image, and then it's checking to make sure it actually got loaded. And let's just make sure that runs first, and then we'll make it appear on the screen. So I'm running CppFront, and I'm running the compiler against that generated code. And okay, here we go. Not declared in the scope, you mean? Okay, okay, that's a different thing. Yeah, right here we have a problem. Right here. Okay. There we go. It's good that we check in between each step so it doesn't have a ton of errors in it that we missed. I'm going to rename this up here. I forgot before. I'm going to call this one background. Okay, so we have the image loaded, but we don't see the image yet. So we're clearing the render. We're presenting the render. It's time to put something on the render. So what we need is the SDL render copy. This one will actually put the image that we're looking at on the actual render. So it copies image to the render. So this is a function. It's going to return 0 on success, and it's going to return something else on failure. But since this is a drawing thing that's happening in the game loop, I'm not going to check to see if this failed, because imagine if you're playing at 60 times a second, and you're playing for 10 minutes. That's going to be, even if you're playing for 10 seconds, it's a lot. It's going to be 600 frames. If one of those fails and it didn't draw one time on the render, and you have a whole bunch of different things that are being drawn on the render, if just one of them fails, I'm not going to shut the game down. It only matters if all the material I need in the game, the images and the sounds and the music, actually loaded into memory. That matters. But if they're not getting displayed one time or something, that's a much more minor thing. So I'm not going to check if this function errors. So this SDL render copy, it takes the render, it takes the texture, and then it takes a source rectangle and a destination rectangle. The source rectangle is going to be what is the square of the image that we loaded. Do we want the whole image, or do we want part of it? Where is that square of the image? For the background, we want the entire image, so we can just use null. We're going to use null for the source directory, and we're also, the destination directory is on the render. How do we want this image displayed? What kind of rectangle do we want it displayed in on the render? And actually, we want this image to take up the entire render. So for that, we're going to use null as well. So it's going to be render, texture, null, and null for this. Later on, we will use a source rectangle, but for this, for the background image, we want it stretched to the whole thing. We're just going to use it like this, and we're not checking for failure. So this is going to be render.get, and then background.get, and then it should be null pointer. And that should draw the background on the. That should be enough to get us an image on the screen now. Okay, and there's the image. So the background is black, not because the background of this image is black, but because the render is black and the background has a transparency. So we will be changing the color of this background in the next video. But for this video, we're actually displaying an image. So let's just walk through what we did real quick. I don't think there was any other parts I've missed so far. Okay, so again, we are using this module, so we got to include it. We set our title. That is the, let me show it to you real quick. This, it will be the title. If you're in a floating window manager like Windows or Mac or something like that, the very top of the window will show the title. The right up here, it'll show a title up here. But for me, it shows here. So when I hover over it, it says background. That's what we set there. That's this string right here is when we made the window. It's using that title string, and that's the title of the window. So so we've loaded the module. We've changed the string, to show that this one is called background. We've made the unique pointer for an SDL texture that uses SDL destroy texture to destroy it for the background smart pointer. Now we are loading the texture, the background reset. We're using from the image module. We have the render and the name of the image, and we're checking to see that it was actually created. We are actually rendering onto our render this time. So this is being drawn on the renderer 60 times a second now with this SDL delay 16 here. That image is being drawn over and over again really fast. And then this is where we were initializing the image module with the funny deal with the flags, where we're getting a flag back, we're masking out the answer, we're checking it against the original flags. And here we're shutting down the image library and then shutting down SDL. And that's going to be about it. Thanks for watching.